Hi everyone, and welcome to our short video session on review of lines. I have actually divided our review into two different parts, and I've shuffled around the lessons that we've learned into a different order. The way I'd like to order our review is by grouping everything into part one under the heading of graphs and graphing, and then so that would be this part. And then our second part is part two, where we talk and deal with equations of lines and any equations that we used in this unit. So this front page is just a guideline of the concepts I'm covering. And I'm trying to do it within 10 basic questions that we will be expecting you to know how to do for your final assessment in this unit. So let's get started with some graphing. So one of the things you're going to be asked to do that you should know how to do at the end of this unit is to graph a line. And when a line is given in the form y equals mx plus b, we know that the m value represents the slope of the line, and the b value tells us our y-intercept. Our y-intercept is at the point 0, b. So if I look at part A here, we're being asked to graph the following lines on the same axes. There's another line down here that we'll have to graph on these same axes. But basically, when I look at this line, I can see that my slope m is -2 over 1. That is my rise and run. And I can see that my y-intercept is 0, 3. So using those pieces of information, I start by plotting my y-intercept. And now I can use my slope to go down 2 and across 1 to locate one point, but I might as well keep going. I might as well locate a bunch of points so that when I draw my line, which I would use a ruler to do if this was pencil and paper, when I draw my line, it looks nice. The more points I have, the nicer it looks. Okay, so that is how I graph a line when I have its equation. Now I'm being asked to state the x and y intercepts of this line. So we know that the x-intercept is where the line intersects the x-axis, and similarly the y-intercept is where the line intersects the y-axis. Okay, and these are coordinates. So I can see that the y-intercept actually we already know from part A. So the y-intercept here is 0, 3. Now the x-intercept doesn't look as clear, but this is where knowing what the slope is can be really helpful. So I know that the slope is -2, meaning between any 2 points I go down 2 and across 1, right? But if I'm halfway between, or if I'm not, but if I look at the x-intercept, I can actually use the slope to help me as well, because I know if I go down 1, well, I have to go across 1/2, okay, to get to that intercept. So I actually know that this point is 1.5, 0. So our x-intercept here is 1.5, 0. Okay, so let's have a look at the next question, which is actually related to the first question. We're being again asked to graph a line, and in this case the slope is 1 over 4 and the y-intercept is 0, -6. So let's do that. I go up 1 and across 4, up 1 across 4. All right, so there we go. We have our line drawn on the same grid. Now, let's look at 2b. This is actually from lesson 7. What does it mean when I say solve a system? So first of all, I know this is a system because of this curly brace here, right? So if I know that this is a system and I'm being asked to solve it, the solve means I'm looking for the point of intersection, or POI, of these two lines. And lucky for us, we already have the two lines graphed. So in lesson 7, we learned there are two ways to do this. One is to solve by graphing. The other is to solve by equating y values, which we're going to do in part 2 of this video. But here, because we already have them graphed, we can say the POI is, and that's 4, -5. Okay, so just a reminder, when I ask you to solve a system, okay, this word solve here means to find the point of intersection. All right, so let's move on to the third question. Now I'm giving you graphs and I'm asking you to state the equation of the graphs. So when we do this, it's typically easiest to think about diagonal lines as having a slope and y-intercept. And we can just read off the graph what the slope and the y-intercept are. So let's start with this one. I can see clearly that the y-intercept is 0, 4, meaning that my b value is 4. And then I want to know what my slope is. So I can take any 2 points, nice points on the line. Okay, and I can see I go down 2 and across 1, 2, 3, 4, 5. So my slope is -2/5 because that is the rise over the run. I'm just counting squares in this example. So my final answer is y equals 4, -2/5 x plus 4. All right, now in part B, the equation or the line doesn't go through nice points. So I'm going to show you how to deal with that. So for example, we can see here that our y-intercept doesn't go through an integer value. It goes through the point 0, 1.5. And that's okay. What this means is that our b value is 1.5, or we can write it as a fraction, 3/2. These are the same thing. Might as well take the fraction. Now, if I'm trying to figure out the slope of this line, I can also see that actually the points don't line up really nicely with the grid. So what I'm going to have to do instead is again go to halfway through a square. So I can see that if I take that point and that point, they're both halfway through a square. And I can still calculate the slope by saying it goes up 2 units, okay, and across 3 units. I can see it goes up 2 units because it goes from halfway between this square to halfway between this square to halfway between this square for a total of 2 squares. So in this case, I know my slope has a rise of 2 and a run of 3. Okay, so just because these values aren't nice doesn't mean there's no line or no equation for the line. The equation definitely exists if there's a line. It just might not always look very nice. Okay, so what about these guys here? Well, we can see that these two lines are not diagonal lines. They're special lines. So this first one is a horizontal line because it's flat, like the horizon. Okay, and we have to know, if you forget this from the lesson, let's just repeat it here, that all horizontal lines have this form, y equals y-intercept. So in order to figure out the equation of this line, all I have to really do is look at where the y-intercept is. So I can see here that the y-intercept is 0, -3. And what's special about all horizontal lines is that they all have a y-intercept, and they have potentially no x-intercept unless they're the same as the x-axis. So every horizontal line has a y-intercept, and so we can write the equation of the line as y equals y-intercept. Okay, so this guy here is our answer. What about this line in part D? Well, this is what we call a vertical line because it goes up and down. And if you don't remember from the lesson, we also learned that the form of this line is x equals x-intercept. And as you can imagine, every vertical line has an x-intercept. So I can always use that to figure out the equation of my line. So in this case, my x-intercept is 4, 0. So the equation, the answer, So the answer to this question is simply x equals 4. Okay, so we will be expecting you to look at a graph and be able to give us the equation of the graph. If it's diagonal, we can use y equals mx plus b. If it's for horizontal, we can use y equals y int. And if it's vertical, we can use x equals x int. Okay, so now that we've covered equations of horizontal and vertical lines, let's graph a couple, because we didn't do that in number 1. We did diagonal lines only. So basically, when I look at these forms, I can see they're not in the form of y equals mx plus b per se. Instead, they look either like y equals y int or x equals x int for all of these questions. So I know that these lines are either horizontal or vertical. So we know that y equals y int represents a horizontal line, and x equals x int represents a vertical line. So if I know that y equals 7 is my line, I know that the y int is 0, 7, and I know it's a horizontal line. And it's as easy as that. For this guy here, I know it's a vertical line. I know my x-intercept is -3. And I can just graph my line. Okay, so that's how we graph horizontal and vertical lines given their equations. Okay, so that ends our first part that has to do with graphs of lines. So remember, we covered graphs of horizontal, diagonal lines, also horizontal and vertical lines. We talked about x-intercepts and y-intercepts. We talked about the points of intersection and how to solve a system of two equations. And by a system, we mean something that has this brace here. So I know how to solve a system by graphing the two lines and stating their point of intersection. So we have successfully gone over everything in part 1. And in the next part of the video, we'll look at part 2, equations of lines.